Good morning, everyone. I'm a Linux sysadmin, and I'd like to give you some insights into we as Linux sysadmins, how we approach a problem. Because we often get faced with a question about, hey, my website is slow. Hey, my website is sometimes slow and sometimes fast. Hey, why does this page give an error in production and not in development? We sometimes get blamed for it. We sometimes just get asked for it. And today I'd like to give you 4 specific examples about how one way of approaching it would be to debug that. What's important for me here is that obviously you all write beautiful PHP code or .NET code or Go or JavaScript code, and you have your layers of abstraction and you try to make it as maintainable as possible. While I appreciate that, I don't care about that because I look at the end result of your code. I look at what your code is going to do on my servers. So it gives me an advantage. It gives me the advantage of not having to know JavaScript or Ruby or Node or any other language. I can look at what's happening on the system level. Some of these examples might be over your head at the moment, but I'll gently introduce you into Linux and into a couple of ways about debugging it. Note that this is not the way or the only way. Just like writing code, you can do something in like a dozen ways. But let's get to it. What I'm about to show you requires SSH access. While I know Kubernetes and Docker are hot and trendy, the vast majority of PHP or applications still run on native Linux servers, plain old boring servers. And most of these examples are applicable to that. You could use it in Docker as well, but it will be a bit more tricky. So I have my 4 examples here. Let's look at the first one that often gets the developer to look at the sysadmin and say, hey, why is my website slow? So we'll load the page. And as you can tell, this is indeed a slow page. And it ends with an error. So every time we refresh, it's still slow. We can probably debug at this point that it's always going to be slow. So let's look at what's happening. Step 1 will be to make this a bit bigger. Every time we load the page, we can indeed see it's slow. So what is happening here? We're requesting a page. Our request to the server is probably going to be fast, but then the server is doing something. Okay, let's log into our server. We are root, because most of what I'm about to show in terms of debugging requires root level privileges. If you only have user level privileges on a Linux machine, not all of this is going to work. So first things first, what is actually happening on this machine? So we can use a tool like top, or what I prefer, htop, because it has some pretty colors. And we can refresh my page, still slow, and we can look at what's happening on the server. There's absolutely nothing going on. We have no CPU usage, we have very little memory usage. So we can deduce that it's not a server overload or a resource congestion issue on this machine. It might be connecting to something else that is overloaded, but this machine is pretty safe. Okay, let's have a look. We know that this is a PHP because the developer told us, hey, my PHP is slow. Let's have a look at PHP itself. So we can look at the processes that are running on this machine. I'll make it a bit slower so the wrapping is okay. PHP usually works by having a master process that spawns child processes that actually handle your code. So we have a master process. Any request will hit this process, and it will use one of its children to execute your PHP code. Now, if you have a lot of children in PHP, my first reaction would be, can we narrow this down to a more limited scope? Because we now have a lot of PHP processes, and one or any of these will be able to execute my code. That's not very useful if I'm debugging. I want a narrow use case, much like you would if you're debugging something. So let's have a look at the config and change it quickly. By default, most applications, most PHP applications use a dynamic process manager. It means you spawn 5 children to serve code, and if needed, you can spawn some more, if you can go away. If I'm debugging something, and this is the part that is usually difficult in production, I like to limit things. I like to make it static in this case, and just have one child process that I know I can look at one child process and what it is doing. If this is not an option for you in production because something does not, it doesn't work in production but it works in dev, you might have to temporarily limit access through the firewall, try to replicate it on a different system, but you're going to want to narrow down the scope of what you're debugging. We'll give PHP FPM a kick, look at what's going on, and now we have one master process with one child process that is not going to go away. Now, one of my favorite tools for debugging is called strace, or strace, depending on how you'd like to pronounce it. And it's an interesting tool because it gives us insight into system calls that are happening. It does not give me insight into your PHP code or your Node code, but it lets me know what is happening on my Linux machine. So strace is a useful command. It's not installed by default, but easy to install. And we can tell it to look at a running process, or perhaps even start a new process, and look at what's actually going on. So if we give it the -p parameter, we can give it a process ID. Where is my mouse? There it is. And we can tell it to look for everything that's going on with this particular PHP process. And right now, not much is going on. We're accepting a new incoming connection. Now, don't worry, it'll get better. If we refresh, this is going to spawn a whole lot of code or a whole lot of system calls that are happening on the system. Now, I don't find this very particularly easy to read. Not sure how you feel about it. Reminds me of my first PHP example. I don't like this, so let's try to make this a bit better. For instance, I see a lot of system calls, but I have no idea how long something is taking, what it's actually doing, and it's not particularly easy to read. So, first trick that I'd like to introduce is, if you're going to use strace, give it the output option. Instead of just throwing stuff on your shell or your terminal, you can say, okay, you can point this to a temporary file. If we do that and we refresh our page, we're not going to see output anymore because we've redirected our output. But something interesting happens. If we were to open this file, we now have a file that we can search, we can grep, we can use a lot of other debugging tools on Linux. Now, I don't want to start a war about Nano versus Vim, but if you start this in Vim, you can get something like color highlighting. This doesn't fix everything, but it highlights a couple of interesting things. Now, I'll disclaim I have no idea what most of this is, but I don't have to know, because I can look at the anomalies and the things that are seemingly going wrong in this code. But I'll introduce one more trick before we get there. If we run strace, we can also tell it to log the times when a system call happened and how long it took. By default, this will only log seconds, which is not very useful. We can also log microseconds, just add a second T. We refresh the page. It didn't magically fix itself, so bummer. We can look at the strace command again, and now we have timings and microsecond timings for each command. Now, as you can see, we started at the 38th second, and I don't have to know what is actually, what most of this code is. I can just start to scroll down, scroll down, scroll down, and suddenly there's a big gap. There's a big gap between something that happened on the 39th second, then nothing happened, and then we reach the 42nd second. Something on my system was blocking or waiting for something else. It's a system call. It's very, very low level. I don't see your function line that called this. I don't see your classes or your composer installs. I just see something in your code reached out to a system call. That could be file level access, network level access. That system call had to wait and return data. This usually happens if you're talking to a MySQL with a long query and you have to wait for the end result. But this stands out because we've suddenly lost 3 seconds out of nowhere. Now, if you start to scroll up a bit, and we see these lines, well, remove the highlighting because that's not very useful. You don't have to exactly know what this is, but a few things stand out. A few things like an IP address stand out, and the port, 3306, the default port for MySQL. I can deduce, without knowing your code, that you're connecting to that MySQL on that port, and that my system is waiting for a response that it never even got. So if we were to test that, we can exit the file. What's listening here? Well, that's peculiar. There's nothing even listening there. So that's probably the reason that nothing answered as well. That could be a firewall issue, the system could be down, it doesn't really matter. Okay, let's fix the bug. We can fix the bug because I wrote the bug. Usually this is the point where, as a sysadmin, you go to your developer and you say, hey, I noticed this on my system, can you explain what's going on? Let's remove that one. I know the fix because we can just look at localhost. And if we look at localhost, there is a MySQL listening there, and we can connect to it. If we refresh now, it's fast again. Now, I didn't have to look at your code. This could have been a Ruby, a Perl, or whatever, but I can look at the system calls that are happening and the result on my system. Now, if you have an idea of where things are going wrong, you might expect it to be file access or network access, you can use strace to filter it a bit more. For instance, if you give it the E flag, you can start to trace particular elements of system calls. If we were to say you'd like to trace only the network calls, you refresh the page, Now I've overwritten my strace file, so it will be a lot shorter. And I see only the system calls related to network traffic. You can use this for file and a couple of other things. So the moment you start to have an idea of where the problem might be, this allows you to filter things down. You don't have to know what every system call does. Most of it can be looked at a glance, and you can deduce certain things. So that's one example of using strace to look at an existing process and see what's happening behind the screens. Something we often get asked about as well is, hey, why is my server running at 100% CPU? Why is everything slow if I load 5 pages at the same time? Well, we can use a couple of different techniques to debug that. Again, this is not the only way. There are plenty of other ways. There are commercial tools that help you as well. So every time I load this page, I can tell that it's taking about a second, perhaps 500 microseconds to load. But this is a really simple page. It ought to be there like snap. So what's going on? Back to our terminal. First thing first, you look at htop. If you refresh the page, what's happening? Well, we can see that there's a PHP process consuming CPU. If all that is consuming CPU is the PHP process, I can be pretty confident that my server is operating normally and something in code is causing CPU cycles. It could be infinite loops, an n+1 issue, perhaps you're loading too many things that you shouldn't be loading, but we have an idea of where to look for. Now, one of the approaches would be, okay, strace and do the entire dance again. Something else I'd like to show you is a tool called inotify. So everything on Linux is probably either a file or a directory. That pretty much sums it up. And the Linux kernel is event-driven. So every time you access a file, it emits an event, and you can listen to that. If it reads to a file, it writes to a file. You can listen to file access on your machine. How do you do that? Well, there's a tool called inotify. There are a couple of binaries in that tool that you can use, and one of them is inotify wait. What can you tell you? Well, I'm currently in the directory where my code is, and I can use inotify wait to tell it to recursively listen to this directory, to monitor it for changes. The dot just indicates that I want to follow this directory. What's that going to do? It's going to set up watches. Much like an event-driven system, you're going to listen to events and display what's happening. If you reload your page, this allows you to see what the system is doing on a file system level on this particular directory. So if you access files outside of the directory or on a different server, that's not going to tell you that, but this shows you what is happening in this directory. And of course, it's a contrived example, so your mileage may vary if you try this on your own code. But what can you see? Well, you can see that it's trying to open a config file, close it again. Open a config file and close it again. Why? A config file should only be read like once, or perhaps never, and just stored in memory. Things like this happen a lot, especially if you're writing loops with unoptimized code, or if you are just not careful about what the result of a loop might be. So let's look at the code. Why is our config file being loaded so many times? I have my example for the very heavy page. Let's look at the code. This is not how I usually write code, but it makes things clear. So we have an array. We loop over the array. And we can see that every time we loop, oh, here's the issue. Somebody is reading a config file, JSON decoding it. JSON is very CPU intensive if you start to operate large blocks. So the fix is probably, let's just pull this out because we only need to move or read the config once, save it, refresh the page, and it's fast again. So what's the result when we look at inotify? If we reload our page, we see that it opens our index.php, which is to be expected. We load our config once, we close the config, end of story. You can use this technique to look at, in the PHP world, to see if your op cache is working. Normally, if you use inotify wait, you should look at the first page hit will be probably slow. You'll see lots of disk access because each and every file has to be read. The second one, ideally, only touches one file, your index.php or whatever, and all of the rest should be in op cache, in bytecode, in memory. If that's not the case, you might look into optimizing your op caches. So inotify wait is a very powerful system that allows you to hook into what your system is doing. This is very noisy if you run Composer with a lot of dependencies, but it shouldn't be. If it is noisy and it remains noisy, it's probably a sign that there's some optimizations that you can do there. Third example, one that you often see where dev and production or staging environments aren't exactly the same, is, hey, I have a page which is working in dev, But if I ship it to production, I just get an empty page, no errors in my log. What's going on? I'm really good at writing pages that error, so this was definitely something that was easy for me to do. I have my error page, and every time I refresh, there's an error. Sometimes your HTTP headers can tell you a bit more about what's going on, but we can see that this is plain and boring. We get a 500 internal server error. Okay, let's look at the logs on the system. We have an error log, we refresh, nothing is happening. Why am I not getting any errors? Lots of code allows you to override an error handler, to ship it to remote syslog, to ship it to something else. Your entire system might be configured to just ship your logs elsewhere, but if you don't know this or you don't have access to that machine, how can you tell what this code is doing or what this code is doing wrong? Well, back to my good old friend strace, and we'll slightly modify it a bit this time. I'm going to use just the output. It's easier to, well, I'll overwrite the file. Easier to read. We refresh the page, so we've now written to this file. And we can see that it's reading a lot, it's reading a lot, it's reading a lot. Ah, this stands out. This line right here says, or the line below, it says, we have a PHP parse, but then it stops. I know that it's a parse error, but where? Give me the damn file name. Okay. We can tell strace to be a bit more verbose about logging those things. We can give it the S parameter. So you'll notice that the previous output, it truncated different functions and different output calls, but we can make that output a lot longer. So if you just add an arbitrary number, oh, that's not going to work, is it? Like this. We refresh the page, and now we've told strace to log to this particular file, but instead of truncating the strings to like 80 characters or what the default might be, we're going to log a lot more. And suddenly, this file is going to be a lot more verbose as well. I mentioned that a PHP process waits for incoming connections. It waits for an accept message. It actually waits for the entire set of HTTP headers that your client sends to be received. Those are shown here. Not particularly readable, but you can deduce a couple of things as well. There's an accept header, there's an accept language header, all of the things your browser would be sending. Now, if you scroll lower and lower and lower, we now have a full PHP error message. This might also be sent remotely, or it might even be dumped in memory somewhere and just never looked at. But we look at the system call. We saw that the system call was writing something, in this case to output, which was never shown. And we can see, okay, we have a syntax error on a particular line. We can look at the line, we can fix the code, and then the problem is solved. Now, this isn't Freek's problem, it's my problem. I forgot a comma. So we can write the code, reload the page, and everything works again. strace is a very powerful tool with the most annoying output mechanism that you can imagine. And it's the power there is that you can look at it, glance at it even, and usually find some clues about where something's going wrong. You might not 100% be able to pinpoint, it's this file on that line number because of this function call, but that's the idea of DevOps. It's about collaboration. If your sysadmin is looking at this, it can start to talk to you. It can say, hey, I'm watching my system do this, it's doing those kind of calls. What's going on in your code? And you can say, my code is supposed to do A, B, and C. We can say, but we don't see the B, we just see A and C. What's going on? So the act of we seeing vague things on the system and then talking to the developer on the other end usually gives us very great insights. Last example that I love to show is one where it's often asked, hey, if I load a page, with a lot of Ajax blocks, why does it take so long for all of those blocks to load? I didn't make one with an Ajax example, I took one with an iframe, but the same theory or the same principle applies. I have two blocks. I have an iframe in red and an iframe in green, and every time I refresh, this takes a really long time. Okay, so first order of debugging would be, why? If I load my page 1 directly, we can tell, this does indeed take a very long time. If I load page 2, hey, this is fast. It's always fast. Every time I reload this page, it's fast. Then why is this page so slow? Okay, back to our debugger. This is usually where any debugging starts. We reload the page. We can see that we're loading our main page, some CSS, and then we have page 1 and page 2. They're being loaded at the same time, but they take 4 seconds each. Yet if I load the second page, it doesn't take 4 seconds. What's going on? Well, Perhaps I should have done this a bit earlier, but the same will apply. I modified our example to get one child process. Of course, if we're going to test something like concurrent connections, we're going to need more than one child process because child process only serves one process. We load this one, we restart FPM, but you'll see it's still slow. It remains slow. Those both calls are equally slow. Again, using strace, we can look at, for starters, what are the PHP processes running on this machine? So we have the master process, and at this point, I don't really care about that. But we have child processes. We can say, I'd like to strace those, this process ID. I'd also like to strace that one. You can do several at the same time and see what they are doing. And to make it a bit faster, we'll tell it that I only want to trace file system calls. If we do this and we refresh the page, we can see that, well, we get a lot of file system information, and then it continues, but it's slow. So the most boring sysadmin trick is to just insert a couple of enters whenever you get output that is supposed to continue, so that you know where to go back to. If we refresh the page again, what's going on here? And I'll Command C to exit this code. We can see that a particular process ID is going to open a session file, and it's going to wait. It's going to wait because it probably wants to read the data for your session. It might even want to write to it. So we have a session file. It sits in a particular location. This could also be memcached or Redis, but the same locking mechanisms apply here as well. So what's going on? We have two pages loading. They both want to load your session memory or your session ID. And one of them is very slow at doing so. So we have a file here, the PHP session file, and we can use a tool called lsof, list open files. And if you were to just hit enter now, it would list all of the open files on your Linux machine. So this is noisy and absolutely not useful. If you list lsof with a file name, it will tell you which processes are keeping this particular file open. Right now, it's nothing because I'm not loading the page, my page has finished loading. If I refresh my page, which is a slow one, I can now see that there are two processes that are trying to open this particular file. Now, this is interesting because I have two process IDs, because I know now these are two different processes trying to load the same file. But one of them has a peculiar flag. So you don't have to know these file handles. It's all in the man page. By the way, if you just type man lsof, you have years of reading to do, but it's super verbose and super explanative. But we can tell that one is opening it for reading, and one has opened it with a write lock. Now, if something is held open by a write lock, it can be an exclusive one, which means that any other process that wants to write that file or read that file has to wait for the first process to finish. The same happens in sessions. By default, PHP sessions are stored on disk. So every time you load a page, your session ID, which if you go to your application cookies, here's your session ID, and the value that you see there is exactly the value that you'll see in the file name. So it's predictable what your file location will be. But every time you load a page and you want to do something with your PHP sessions, it's going to load the content of that file, so the serialized content in PHP, load it into memory, you do your page, and then close it again. Now, if your page is loading sessions, and it is doing something computationally intensive, it's just very slow, it's going to have that lock and only release it when the moment your page stops loading. Now, if we were to look at the code here, so we have an index file which is irrelevant, and then the two pages that are loading via Ajax. If we were to first look at page 2, what happens is, well, you have the typical session start. You might read from session, write to session, you name it, but this opens an exclusive lock on that session file. If we look at page 1, our slow page, well, obviously it's slow because I added a sleep, but that's for debugging or for showing the purpose. You can also add in your code a deliberate statement that you want to release the session lock that you just opened earlier. So your code is still the same. You define a session name optionally, and you session start to read your session data. But if you know that you will not write to your session anymore because you're done writing the session and you're now flushing output to the browser, you can deliberately close that write lock that you have on the session file. So if we do session write close, we close the file and we reload the page, you'll notice that Page 1 is still very slow because that makes sense. My sleep is still in there. But page 2 is no longer blocked by the file lock that accidentally got opened in page 1. We can tell, because I'm refreshing the page, but I still have my same session ID, so the file name is still the same. If we reload, there's no longer a lock on that file system, on that file. The second page, which loaded quickly, has opened the session file and immediately closed it because the page finished loading. The first, slow page, is still slow, but it opens the session file, does its thing, and then closes it straight away. It's a lot more efficient, of course, if you don't have to wait for a lock by an independent, different process. This does open the door to a lot of interesting race conditions. If both of your AJAX calls or iframes were to try to write data to your session file, funky things might happen. But this is an example of using native Linux tools. lsof is about the most native tool that you can imagine, to look at what your system is doing and what is holding locks on files or you name it. There's another trick that you can use. So we have two PHP processes. One of them is going to be slow, one of them is going to be fast. And Linux offers a virtual file system under proc that gives you a lot of process information. And I mean a lot. It can be as verbose as you'd like. And it has a directory. So if you were to go to /proc, then a process ID, there's a directory called fd, file descriptors. Loosely named file logs, which file handles are you opening, etc. By default, it doesn't really open all that much. It has some sockets to do some internal communication. If we reload the page, I'll have to release the log first. So we'll make the page slow again. We're not going to write it, not going to release the log. Refresh the page. And now you can tell in /proc, the process ID, and then its file descriptors, what file that particular process has opened at that particular time. It doesn't tell you what file lock or how big the file is or how much was written to it, but there's a different approach at looking what is happening on the system level. Every time we refresh this page and we were to look at the contents by just using ls, in the file descriptor page, file descriptor table here, we can see a lot of information as well. This is useful if perhaps lsof is not available, the output is not useful. There are different ways of approaching it and having similar conclusions. And with that, I'd like to wrap up by just confirming that there are a lot of ways that you can debug an application. You have Xdebug in PHP, you have commercial tools that you can install and run on your machine. But there's a different side, the back side of the server, where if you have SSH access and you are sufficient in Linux, you can look at an application without knowing the context, without knowing who wrote it or what's the purpose, but you can look at the end result of your code, because no matter how beautiful your code might be, it serves a purpose. It serves a purpose to talk to a database or to talk to a file. We can look at that end result. That end result tells us what's actually happening on the machine. You can use tools like strace, which is my personal favorite and perhaps my hammer with which I prefer to work, which doesn't always work, especially not in Docker or Kubernetes environments, but it gives you a lot of insights into what an application is actually doing. iNotify-Wait allows you to look at system calls that are the events that are happening on the file system level and hook into that and see information that your Linux system is emitting. Alternatively, lsof and all the information in /proc gives you a huge amount of insight into what an application is doing on that system. If you have any other questions about debugging anything, I'm here for the rest of the day, so feel free to reach out. That was my presentation. Thank you.
Thank you, Mattias.
Sorry.
That was very enlightening. I hope I don't have to use those tools, but probably everybody gets into troubles at some time, so it's good to know these.
There's a reason there are more PHP developers than sysadmins, so
yeah.
The ratio is different. Yeah.
I wonder something. In the PHP, you've been a sysadmin for over 10 years. And in the PHP world, a lot has changed in the last 10 years. And in the JavaScript world as well. But what has changed in the world of operations and DevOps? What are like the big things that have changed there?
The things that have changed definitely for the better are there used to be a time not that long ago when most of our sysadmin stuff would be to log into a machine, make manual changes and log back out and hope for the best. Much like development has gained abstraction layers and frameworks to make things easier to manage, the same has happened on the sysadmin side, both Linux and Windows, by the way. So we have tools like Puppet, Chef, Ansible, where we can use infrastructure as code, so we're writing code to define what our system should do. That's definitely something for the better. You can take that to more extremes where you end up with Docker, Kubernetes, or even more advanced setups. But all of that has made it so that we can test what we do and that we have predictable outcomes. So I think the same goals that you have as a developer are ours as well. Our tooling might be a bit different, but we've just been adding more and more tools to our stack as well to make it more easier to manage and maintain.
Yeah, and make it more predictable then.
Yeah, exactly.
Where can you learn these things? Do you have any good resources for like developers where they can get more information about DevOps stuff?
That's the hard part, I think. I learned most of what I know right now by having an issue and Googling for it, and just Googling a lot for it. There are really good courses that you can follow by Red Hat, by other services. But they are intense, and depending on if you want to make a career change, it might be worth it. If you're just a developer and you want to learn more about PHP or the sysadmin side from everything, instead of blindly executing a blog post that you found, and I'm guilty for it because I write those blog posts.
I execute the code that you write on your blog.
I can punish you now. No, just try to understand what's going on, and if something is not clear, look it up, Google for it. I find the sysadmin side very interesting, especially with some PHP knowledge on the other end. And I find everybody gets better if you understand both sides of the world. So yeah, Google still remains, unfortunately, the best place to learn these things.
Okay. Might be a good hobby project for somebody to create a video site or a content site with this kind of information. You've come across a lot of backend languages. Why did you stick to PHP, or why is PHP your main focus and not like Ruby or one of the others?
Well, I started writing PHP over 12 years ago, so it was my first love, I think, but it's such a powerful language as well. Even if you look at, disregard any framework, the things you get out of the box with vanilla PHP, the way that you can work with arrays, the ease of use to connect to databases, it's feature complete in a lot of ways, and you don't need to know all the advanced things or the new syntaxes in PHP 7. I started writing PHP 4, and that knowledge still allows me to write PHP 7. Yeah. I guess the same would apply if you once learned Ruby. It still applies today. Yeah. So perhaps a bit of laziness to stick to PHP, but at the same time, it can do everything that I want to do. So it's still a powerful language.
Okay, good. That's all we have time for. Thank you, Mattias, for your excellent talk. Can I have another round of applause?